cast iron, grade 40, aluminum, 2024, and steel, 1018. So these are the steel. They are blue edges. So 2 steel, 1018, 2 aluminum, 2024. They are red on the edges. And then we've got copper here for cast iron. Okay, grade 40, doesn't matter so much. Okay, so what is the goal of this lab? The goal of this lab is to sort of show you what it means for a ductile impact or a brittle impact, okay? There is one other goal though. We have 2 aluminums and 2 steels. We're going to do them at 2 different temperatures. So what happened was during World War II, they would design these ships. What are ships made out of mostly? What material? Steel, right. So these ships are made out of steel, and during World War II, they designed these ships. And the problem is that they sent them into cold waters, right? These really cold waters, usually, at least near freezing, if not below freezing. And these ships would get impacted. What would they get impacted by? Many things. They could get impacted by actual torpedoes. They could get impacted by ordnance, like artillery from other ships, etc. Right? They could get impacted by a lot of things. What was the problem? These ships would split. So the problem is that certain materials under different temperatures, they react differently than they do at normal room temperatures. So they didn't take this into account. And so what happened was the steel they used became brittle, right? It started acting more like the cast iron. So it's not brittle like cast iron, but it became more brittle. So it's still ductile, but it didn't have the same strength. So that's what this lab's going to be about. We're going to talk about impacts in general, and then we're going to talk about the effective temperature on impact. Specifically, we're going to talk about for steel and aluminum, the effective temperature. I've got this here, so I can sort of go through it. Tell you what we're expecting to see. So